Now we should be recording. So this is just for my record, so I remember what recording it is. This is week 5 where we're at. This time around on the evening of Wednesday doing a session as well. So it's a 8 o'clock evening session that we're having a look. And I'm just going to go first through just really kind of the big things that I have shared with other groups or morning group about what have we learned, what sort of things did I notice about the exam and so on, and other practical things. So that's the plan for today. But I think this is going to be a little bit quicker and smoother than normally, since I've already done a trial run in a way.
Awesome.
Basically, what I just want us to focus on is that we talk a little bit about the exam 1 and lab practical. And I still want to emphasize what I said about the missing assignments or retaking assignments. And this week, we're doing a lab in a little bit different platform than before. So I want to take a moment just to explain how that works, because that's the one that students normally find challenging. And I really think it shouldn't be the challenge of the lab to get into the lab. It should be actually all about being able to focus on the learning material, not on the technology aspect. So that's one more thing that I wanted to talk about. And then we'll review this week's chapter. But really, I don't think there's anything too curveballs that we would not have seen before. But just kind of an ad, I had this for the morning group that we're trying out if we are getting or being able to build up a little bit of participation for the evening sessions on Wednesdays in addition to the morning ones. If these work, and even if I get one person, I'm happy to keep doing these, so we can kind of plan of having those as more regular thing. But if it doesn't work, I can do something else by myself as well if no one shows up. And we can also look at other days. We can look at other times. I'm here wanting to make this work for you guys. So you just let me know, Melissa, who's here, or anyone else who is watching the video, you let me know what works for you. That's my job. That's my role here. I want to make this work with your schedules. In terms of just the last exam and the lab practical one that we had, some of the students, I think that I did a little bit poor job on being clear about this. And part of it was that I probably did it a little bit strategically, because I shouldn't be doing things too differently from other instructors. But at the same time, I have the full freedom to do things differently. But I really, really meant that it was going to be an open book tests, and there was no need to have Respondus, the software that analyzes that you're not cheating and all that. What I care, since we're not doing traditional exams in a classroom setting, is not that if you look your notes, that's fine. I don't even care if you look for answers, because I think exams, tests, practicals, that's just as much of a learning chance and learning opportunity than just a traditional chapter. So I'm all about having that available, those resources. So don't hesitate if I don't especially ban you from doing something. You can do whatever you can think of. You can even do it as a small group, the tests, for all I care. But I need to get a submission from everyone. I'm totally open. We could even do, if someone felt that was really useful, that you could be taking a test during one of these live online sessions, that we could be basically walking through the test as a group. I'm totally cool with that as well. I just need everyone to submit something. Like I said to some of the others already, and if anyone missed that, I am just finishing off the manual review round. I've done it now, I think, 3 times for each exam that I received from each one of you, just to make sure that I'm being consistent with giving points, even if there would have been small spelling errors or anything like that. I should have that all finished by the end of the week. The goal for me is that even if you don't know the exact answer, as long as you can demonstrate to me that you know something, you know the material, That's what I'm looking for. And I think that in terms of grading, that's going to be a bigger change with this COVID thing and whole other aspects of that we're going to get rid of traditional exams. And we're going to go more towards the direction of students being able to show that they meet the learning outcomes or they meet the competencies. And how you show that to me, I'm totally cool with that. I'm looking into something that's known open pedagogy. And in a traditional classroom, not on this one, but in a traditional classroom, what I do is I give the learning outcomes for the course at the beginning of the semester to my students. And then I open the floor that they can demonstrate those in any way they wish to me. So it can be essays, it can be taking exams, it can be taking tests, but it can be also making a project. It can be making a presentation. I even had one class making they acted a play about how action potential traveled within a nerve cell. And as long as they show that they know the material, I'm totally cool with that. So we're not quite yet there with this course, but that's definitely the direction where we're heading. So I don't feel that you have to take the tests as you would take in a classroom. What I'm wanting you to do is take the tests and learn while you're taking the tests. But anyways, if you want to go through your test, and I'm referring to you, but I'm referring to anyone who watches this as well. If you want, once I've sent back your final scores, if you want to go through question by question, that where did you get the points, where did you lose them, I'm happy to do that as one-on-one. I usually avoid doing that as a group because then there's issues of not sharing someone else's information in a public setting and so on. But there's totally an opportunity for that as well. And I'm totally open also if anyone wants to reattempt either the exam or the lab practical. Really, what I want you to do is get the points that you want to get. I'm not going to give you an A just because you said you want an A. But if you're going to do the tests again, do the practicals again, and that moves your grade to an A, I'm happy and you're happy. So that's my philosophy behind this. That applies to, and I think that I mentioned this last time, also to any assignments that we have already done. Some students, and there's not many of you, those students, you guys have been amazing in terms of getting the work submitted in. I don't know whose classes you've taken before, but that instructor has really whipped you into being strict with the timelines and so on. What I care about is that you get a chance to do those. Whether it's on that exact date, that's not a big deal for me. So I'm happy to open up any assignments that you might have missed the deadline or any assignments where you feel that you didn't get the grade that you really feel that you could achieve. So I'm totally okay with you going back to those and you having a chance to kind of regain your results if it wasn't what you wanted to be. How we're going to do that is that I would ask you to message me. And the reason why I'm asking you to message me rather than to speak to me is that there's so much going on. I forget it. If it's not written message, there's a greater chance that I forget it. If you send me a course message saying that, hey, this is the assignment that I want to do again, there's much greater chances that I actually remember to follow through on that. So be very specific when you send me that message, that what activity it is. If you just say that labs in general, it's going to be hard for me to go through every lab. But if you say that this lab, and this lab are the ones that I would like to do again, or if you say that this exam or this practical or this quiz, I am totally happy to open those. The points that I have there on the slide, reflection and why you are retaking something, you don't have to explain to me. I just want you to succeed. But it's probably worthwhile if you're retaking something or you're tackling something for the second time, kind of reflect a little bit that, okay, how did I do it last time? And since you're telling me that you're wanting to do it again, in your mind, consider that how do you think that you're going to do better on it this time? Or do you have a new strategy? Or do you have you've just learned more? Or whatever it is that kind of take that chance also as a chance to reflect on that and figure out a way how to improve. Of course, you can be retaking the tests, you can be retaking the assignments 100 times, and you're probably going to do better. Because essentially what I'm going to take is the best score that you did. That's what's going to count to your final grade. But it might be useful that you don't do it 100 times and just hope that based on pure statistic odds, you guess the right combination in a multiple choice. I'd rather that you do actually kind of think of, okay, this time I'm going to have really nice notes, for example, in front of me. Or this time I know how I should lay out my notes. So that different strategies. So that's all I ask from you. But other than that, I'm totally happy with you doing those assignments again. So that was kind of the general spiel of what I think I've said before, but making sure that everyone hears the same stuff. I also wanted to quickly talk about this week's assignments. So there's a lot of similar stuff that you've already done in Connect, the Learn Smarts, where you basically work through the chapter and it keeps asking those questions and again. And if you work through it, you will always get the 100%. Then there's the quiz. You've seen that format again as well before. And then there's the practice anatomy that you've done before. And all of those are due at the end of the week. And there's the points that are associated with those. But the big difference to the previous weeks is that we have 2 labs that we are doing, and these labs are done in a little bit of a different format or a little bit of a different platform than the way that we've been doing labs before. And it's not just because I want to mix up things. It's absolutely not. So these labs were originally designed and developed by McGraw-Hill, our publisher, back in the day, before the Connect was built to be what it was. And these labs in particular were so good in that previous version that we still want to use those, even though they're a little older. But because they're a little older, McGraw-Hill doesn't really put in a lot of money and effort and time and all that of supporting the way they have been set up. They're just kind of historical things that are there. So there's a little bit of a hiccups that some students usually find when trying to access these labs. We will be using the same lab platform that you'll be using now in a couple of other labs throughout the course, but majority of the labs will be the labs that you've done before. But that's why I want to take the time now to go through those and show how you troubleshoot if you run into any issues, so that you are also set for future labs as well. So there's 2 labs that we'll do, and one of them looks at the EGGs, abnormal ECGs, and one of them looks at the heart sounds. So let's have a look what's different in this lab setup. These labs are taken with, I think it's a software or a product name, Phil's Labs. And Phil's Labs is based on, like I said, on a little bit older technology. It's fully dependent on Flash Player. And as many of you know, Flash Player is a little bit of like an antique way of working in online setting. It's had its heyday, and now actually Flash Player is going to be totally retired at the end of this year. So a lot of publishers are kind of in a situation where they are now realizing that, oh crap, we need to figure out something new. So, but until that happens, we are still going to be using the Phil's Labs. So because we're using the Flash Player and majority of the web browsers don't support Flash anymore because we're preparing to retire it, you might run into issues how to get your web browser to run the Flash. So I just want to go through the most common hiccups where students run into those. But we have a great amount of resources available as well. And that's what I was trying to show here on this slide. On your Canvas course, on this week's module, have a look of those help with Phil's Labs. There's 2 videos. I think each one of them is like maximum of 3 minutes. So it really isn't going to take a long time. But just so you're prepared, if you're going to take these on Sunday evening at 11 o'clock, so that you're prepared that it might not be as smooth as it has been in the past to take labs. And I'm totally fine with that as well. If you are now totally thrown off by this technique or this technology, then we'll just extend these labs. But what I want you to know is that you don't panic that, oh no, that now it's something that I wasn't counting on. So I'm giving heads up that there might be a little bit of a battle to get into those. So have a look of those resources. It's just something that I want to advocate. So how to make these things work? When you go to the lab, these labs, you'll probably get a warning sign if you don't have the flash activated on your browser. Something like this, that it's going to say that you will need Adobe Flash Player, either get a new version or fully install it or enable it. So some sort of an error message is quite expected. So whatever the computer says that if you have to install it or if you have to activate it or if you have to do both, do those, because until you've done those, you will not be able to access the lab. Sometimes you can actually use it also without the newest version because they're not really updating these versions anymore, like I said. So there's two top spots where students usually run into trouble. And I've covered both of those. And both of these places where students run into the trouble are on your browser next to the address line where you write the address to what web address you want to go. Or when you're browsing, it updates that address that, oh, this is this and this and this site. So you'll actually see what bookmarks I have on my computer, which is probably really sad. I shouldn't share that, but you'll see those screenshots that I've taken. The first where students find trouble often is actually located at the end of the address bar on most browsers. There's usually a star if you want to bookmark stuff or something like that. But when you are trying to run a Flash player, there might be a lock and there's a slash through it, or there's some sort of a red signal that no, you cannot do this. Well, click on that symbol and choose Allow Flash. So that might be the first time where your Flash player gets blocked by the browser. And that's a safety feature because there has been problems with the Flash and safety of that. So just so you know that that might be something that you have to do. Well, the weird part is that even if you have enabled or allowed the Flash on there, you might have to do it again. And this spot B is what students often they've already allowed the Flash once, so they're like, it's not working. But you might have to do it again. Or it might be one or another of these. So then you go to the other end of the web address bar that you have there, and there's often a symbol that's kind of a circle and an exclamation mark inside it. And there might be a text as well that this is not a secure site. Are you sure you really want to go there? Well, you click on that and you choose that Allow the Flash player. And if you do both of these, you have great chances of the Flash player actually working. And this is not a student, but a colleague who sent me a screenshot of this, what it looked like on their computer. So there's that exclamation mark inside the circle, and it says that this is not a secure place. Well, when you click on it, it opens up this kind of a little window, and there next to the Flash, you have a drop-down menu where you choose that Allow it. If you do both of these, you probably should be able to access these FILS labs. So just kind of a heads up that you might have to do extra steps. These all are going to be the instructions also on your Canvas, so don't feel like, oh, now I didn't catch that. You can come back to these videos, you can go to the other videos that have been made available. But once you're in, once everything works with the Flash, you will end up on a website that looks something like this. There's a big kind of a table of contents or a listing of various different labs that are being offered on this FILS lab software. Well, I don't want you to do all of those. And the other thing is that this, since it's all technology, it's a little hard that when you just click on to do the lab, You don't actually get directed to do that lab. You just get directed on this big table of contents, and students are like, well, normally I get directed to the right lab. Will I now know which lab to pick out of these? Well, you want to pick the lab that matches with the name of the lab that I told you that you should be doing. I think the first lab that I told you to be doing is lab number 30, abnormal ECGs. So just based on the name of the lab that I've given, you just look for it. Where do you find it? I think the other lab was something to do with heart sounds, if I remember correctly. It's been a long day. So you'll find it on the canvas and you'll identify, and then you click on that particular lab activity, and it will open it, it will load it. So here's like step by step. I actually did this today a couple of times. So every click that you needed to do, you need to click quite a few times. You first need to click on the lab that begin the lab and continue, and then click here to access fields. So there's multiple steps until you get to the table of contents sheet that I just showed you. And then there you choose the lab that you want to do. Once you choose that, you still have to click next. There's like multiple times checking that you really want to do it. Every time that you start to do a PILS lab, it kind of tells you that how the lab software works. So if you've done something before, you can just skip through it. It's kind of an information. So there's next buttons there. And then once you're in the lab, there's a component that's labeled as a pre-lab quiz. That's a quiz that kind of covers topics that you might learn or that might be relevant to that lab, kind of getting you oriented on that and getting you prepared on what might come up. But I am not gonna let that affect your grade, whether you do it or whether you don't do it. So it's an optional thing to do. Some students really enjoy that they kind of get their mindset to what they will be working on. Some students just want to get to the business. So I'm just saying that it's optional. You choose whether you want to do it. Then when you actually move on to the actual lab exercise, that all happens on that PILS lab software. And it's like a lab setting, but all on your computer. So you'll be doing various experiments. I think that there was on this lab, a girl, and I don't remember what her name was, but let's just say that her name would be Anna. You make Anna do different things. So you learn about her ECG and you'll see how we can make her ECG look really weird and how we can fix it and all sorts of things. So you'll actually use a virtual test subject on that lab. While you're working through that lab, I encourage you to leave open the window that you had when you first clicked, because that window will jump to connect. And within connect, you will be filling a post-lab questions at the same time as you're completing this lab on the PILS lab. So it's basically asking, okay, what did you do to make Anna do this and that? And then when you're doing that lab, you fill in that. So not so that you first do the lab and then you have to think afterwards that, oh my God, what did I make Anna or whoever it was to do? So I recommend that you do those at the same time. So you will be filling your post-lab questions while you're working on that lab. So in two different screens. So be prepared that you might need to be jumping around. Of course, nothing prevents you can just do the lab first and then go to the post-lab questions. But that's a little bit of a kind of a downer, having to think back that, oh, what did I really do? And a lot of times students end up having to do it again. So that's why I'm just putting it out there. But what you want to do so that you submit it and you get points for it is that you want to make sure that you complete the post-lab questions, and those get completed in the Connect, not on the PILS lab. You can also do those same questions on the PILS lab, but do the ones that open up when you click and when you're working through the PILS lab. There's a previous window open where you will complete the post-lab questions. It's going to be much more clearer once you start working through it. Trying to explain it verbally sounds weird, but it's not that big of a deal. The biggest deal is just to get the flash working. And because I'm always aware that this is a product of the McGraw-Hill, They even themselves say that it's a product that's antique and that doesn't really work on modern computers. And I get it that they're not want to invest a huge amount of money and time to fix it only for the remainder of the year before Flash gets retired. So they just say to us that just tell your students to phone us. They are expecting those phone calls. Their technical support team knows exactly what students are running into. So it's not like I'm not here to help you. I'm totally happy to help you, either on our weekly meetings or in other meetings or one-on-one or through messages or whatever. But also, if you want, you have a chance to contact the publisher. And I promise you that they know their product inside and out. They have probably like 100 students a week who all have the same question. So there's their phone number, and they're totally willing and helpful to assist you. And for anyone who just wants to hear it on the recording, the phone number to the McGraw-Hill technical support is 800-331-5094. And you'll find that number. I've loaded also it onto Canvas like 100 times just so that you have it somewhere. So don't hesitate to ask for help. That's what it's there for. So I think that that's all I had to say about the Phil's lab and the lab stuff. So far we've actually covered quite a bit of what I said that I wanted to go through today. Oh my goodness. So the last thing that I have left is to review this week's lecture material. And I think that I did prepare the videos that I normally have, kind of lecture videos for you. You click on a thing and it takes you to YouTube. But I'm not sure if they have been yet published because they were running on the background, the subtitles on it. So it might be already up there. If it's not up there, it's going to appear in the next like 30 minutes or so. YouTube takes a while before it releases the video once everything has been completed. So those videos will be available there, and they're like the full story. What I was going to do today was to give you like a condensed story of the key points on this chapter about heart. And we'll look at the anatomy of the heart and we'll look at physiology. It's almost divided in two sections. But as you know, since you're now on the AMP2 course, that anatomy and physiology are not really separate topics. They're kind of often interlinked. So every now and then we jump from one to another. I love that you're showing it's all connected. So I have a bunch of slides that I picked from the original material that I thought that were most important ones. And what I'd like to do is talk through this chapter with you, but I don't want it to be like a dictator lecture from me. So at any stage, feel free to shout out if there's questions. I think on our morning class, there were many good questions that kind of then made me think that, oh yeah, I kind of assumed that you all know this, but of course you can't know because I haven't explained it yet. So sometimes we end up doing these things, these classes so long that we just assume that students should know some certain things that we haven't yet taught. So what I put here as the very first one, and I kind of want to start with a warning that heart is what I've done for a living. And 3 blood vessels that I'll show you out of the heart is what has paid my bills for the past 10 years. I've been researching just 3 blood vessels in a heart, and that has managed me to make a decent living. It's a very, very dear and near subject for me for that reason. So I'm a little bit probably even overly enthusiastic about this chapter. So I might go into a lot of detail. I'm trying to keep it very basic because you might not love heart as much as I do. But just so you know, if it sounds like there's a lot of information, it's probably just because I'm really excited about the topic. But I think the great way to start any chapter is to tie what we're talking about into something that we've seen before. And we've definitely seen before 3 different muscle types. In one of our introductory biology courses, it probably might have been BIO201 or BIO156 or whatever course you've taken. We mentioned there that there's actually 3 different muscle types. And the skeletal muscles are the big muscles of the body that move us. If you're an athlete or bodybuilder, it's especially the skeletal muscles that you're growing and bulking up. So we've seen those before. Smooth muscles, we've seen those when we talk about, for example, the regulation of blood vessel walls. So that regulates the diameter of the blood vessels, also regulates the passage of the food in intestines. So in the digestive system, and we'll actually talk about digestive system later, and we'll actually talk about blood vessels as well. But smooth muscle, there's not a great amount of that visible, but it does its job without really conscious control. So it's a lot of the time something that's just there and does its job, and we don't realize that it's there until something goes wrong. But for this chapter, our interest will be on cardiac muscle. And cardiac muscle cells are a special type of muscle cells. And the reason why they're special is that if you think, what's the job of the heart? What do we really want those heart muscles to do? We want all of those muscle cells to work together, work in uniform. Because if one cardiac muscle cell does one thing, another one does another thing, that's how you get a cardiac fibrillation. Your heart just goes crazy. And we don't want to do that. So cardiac muscle cells are adapted to be able to be very synchronized. And some of the adaptations that you might have seen before included, for example, these intercalated discs. So these muscle cells have a lot of branches, the cardiac muscle cells, and these branches are connected to other branches so that messages, signals can be passed really easily from one cell to another. So that's just kind of a reminder. This should be all familiar stuff regarding this muscle type. And we only find the cardiac muscle cells within the heart. We don't find it anywhere else. So just kind of heads up that that's something that you might remember from the past. And I think that the other thing there's an example of close-up of an intercalated disc at the end of one cardiac muscle cell and another cardiac muscle cell. So you can see why passing the message from one cell to another would be easy. The other thing that I added here is a bunch of pictures of mitochondria. So heart muscle is the one muscle, heart really is the one organ that's constantly at work. Even if you think of our brain gets a break every now and then. You might be sleeping a dream where your brain is not active that much, or you might be just zoning out and watching Kardashians. I don't have a TV, so I don't know what's on TV, but I would assume I've seen little snippets of the Keeping Up with Kardashians, and I don't think that there's a lot of brain activity that needs to be going on when watching that. Okay, I don't know. I'm just getting signals that I haven't missed anything. Really, I don't know. I haven't had a TV in the past 5 years.
Yeah, you didn't miss anything.
Okay. Maybe it was a good thing that I didn't watch. But either way, what I want you to know is that heart is constantly working. So heart needs also constantly energy. And you remember it was the mitochondria that converted sugars into ATP that was then used as energy. So you end up finding a lot of mitochondria also in the cardiac muscle cells. So just kind of a reminder. I think the other good thing to talk about when we start talking about an organ is where is it located? That's always like a good thing to know. So we remember our heart was located within our chest cavity, within our thoracic cavity. It's located roughly in the middle of it, just slightly to the right. And remember, when we're talking of directions, it's the directions of the patient's right. So heart is just a little bit to the right of the midline. At the anterior part, so forward part of your chest cavity, just above the diaphragm. You remember diaphragm was this muscle sheath that separated your thoracic cavity from your abdominal cavity. That's the one when you get hiccups that's bouncing, that muscle. And heart, if you want to, I often do this at Valentine's Day, which is probably a reason that tells why my life is so lonely. When people say that way to get to someone's heart is by giving them a nice meal or this or that. I'm like in my Valentine's Day cards. No, it's between the second and fifth intercostal space. So you count your second rib, you count your fifth rib, and between there, that's how you get to someone's heart, really. It's nothing to do with these romantic things. Oh my God, I seem such a creepy demonstration how to get to someone's heart on a video of a student. But I did do postmortems for a living. That's how I funded my way through the university. So I know how to find the heart. You just crack open the rib cage. But really, we want to know that it's slightly right from the midline and between the ribs 2 and 5. And you really, if you're considering why would you need to know that, if you're going to go to the profession where you're trying to listen to the heart, for example, with a stethoscope, as a nurse or as a medical professional in any other field, you'll learn to kind of visually assess where it is. But at the early days, it might be that you actually have to count the ribs. That, okay, here's the second rib and a gap underneath it, and let's go to the fifth rib. Because you want to get it right. You don't want to be taking ECG from somewhere where there's no heart behind that. Because then you just won't be doing your job right and you'll make your job even more harder. So that's just kind of to give us an idea where the heart is located. The other thing that we'll notice is that heart is actually inside a sac. It's like having two Ziploc bags that are inside each other and there's a little liquid in between those. And often I kind of, in a face-to-face class, quiz my students, why would you put this heart into this Ziploc bag? And they're like, oh, I hear all sorts of creative answers, but I'm seeing an answer on the video. It's absolutely to allow it to move easily. If you think the heart is squashed or placed between the lungs, there's a lot of stuff around it. And this other stuff could kind of push and make the heart into a situation where it's hard for it to move. But by having this sac around it, we ensure that it can move, it can pump without any issues, anything holding against.
Friction? Without friction?
Friction, that's the word that I was looking. See? Perfect. I'm going to remark that I'll remember to keep your extra credit. So basically, the fluid between the two bags is to reduce the friction, allow the movement. The other reason why we often see different organs in your body in various different sacs, if you think of that from your AMP1, I think that they should have mentioned on that. That's also to prevent spreading of inflammation. If you have inflammation in one part of the body, well, you don't want it to spread everywhere. So that's why we kind of do these compartments of body organs. So that's another thing that might play a role.
Is it the same as like, is it the same as what we have, I think between our ribs and our lungs, the pleura
layer there. Absolutely. That's the same concept. Our lungs are able to move because we have that negative space. Again, a double layer where there's actually negative pressure there that keeps pulling your lungs open all the time. That's why if you get stabbed to your rib cage and you break that sac around the lung, your lung might actually collapse. It's the same thing, and we're actually going to talk about that later on this course. But you'll notice actually lungs come way lower than most of us think about it naturally. But I'm going to save the discussion of the lungs, but you're right, the concept is the same. So there's just a kind of a closer picture of the sac, the two layers. So we have our, I'm trying to move things and it's not going great. So don't feel that I'm doing something dodgy. So what we have there, we have parietal layer and visceral layer. Those are the two terms that, the different layers that form that sac. And in between those, we had a pericardial cavity. That's the one that's filled with the fluid. But all of this, you'll hear more detail on those lecture videos, but this is the level of detail that I want you to know. Just that there's a sac, two layers, liquid in between, reduces friction, allows the heart to move. What else do I have here? So sometimes you can have an inflammation of the sac itself. So you remember when you study your medical language, if it's itis, it's an inflammation of something. Now it's pericarditis, so it tells the location. So this, I don't expect you to remember all the details. I'm just wanting to show you that there is a clinical relevance to the anatomical stuff that we talk about. So that's all I wanted to highlight here. This is where we get to the real business. And I don't know how much of the heart you have covered in previous courses and so on, but I'm going to assume that we all start from zero. So if you already know, this is easy peasy for you, you already know a lot of stuff. Don't feel that I'm patronizing you on this video if I go to the basics. So there's many different kinds of hearts, and I think I start my very first video by comparing different animals and how hearts differ from different animals, and not all animals even have blood in their cardiovascular system. They kind of have something else. Not all animals have closed cardiovascular system. They might not have blood vessels. Not all animals have cardiovascular system where the blood flows one way. It can be going any way it wishes. But we're going to be focusing on human body. So I'm not going to review that with you. You can have a look of that on the video if you're interested. I think it's always fun, but that's not the main point of this lecture. What I want us to remember from this chapter is that a human heart, and this is a very wiggly drawing, there's a lot of detail on that, and I'll show you how to draw a heart in much more easier way in a bit. But what you'll notice that human heart contains 4 different chambers. There's an atria, and then there's ventricle. And there's that structure on both sides of the heart, on the left and on the right side. So you have right atria and right ventricle, and then you have left atria and left ventricle. So some say, if you talk in a poetic manner, that human heart is like 2 hearts beating as one. Isn't that beautiful? But there's a reason behind that expression. Because actually, if you look where the blood goes and how it comes back to the heart, it's almost like we have 2 different circulatory systems in human body. And the 2 halves of the heart, one half takes care of one circulatory system, and another part of the heart, one other half of the heart, takes care of the other circulatory system. So if you have not heard before about I'm not trying to show anything, I'm just trying to put a window down. If you have not heard before about pulmonary system or pulmonary circuit in terms of when we talk about cardiovascular system, this is a good time to hear about. And whenever we talk about something that's named pulmonary, we realize that has something to do with the lungs. So if you look at on this diagram, this individual's right side is completely focused on the pulmonary circuit. So the right side of your heart receives blood from the body and then pumps it to the lungs. And then the blood comes back from the lungs. That's the function of the right side of your heart. So that's the one heart, if you wish, of that analog of 2 hearts beating as one. And what you'll notice that all the blood that's coming to the right side of the heart is deoxygenated. We saw this concept of the color difference in the blood based on the amount of oxygen that's being carried by that blood in the last chapter when we talked about the blood. Of course, blood isn't blue when you actually look at it. It's just a dark or purplish. But just to make our life easier on these diagrams, we often do over-exaggerated color difference. So don't expect to see blue blood, but you will see that blood is distinctively different color because there's very little oxygen. And that kind of makes sense that the blood that's coming from the body to the heart is low in oxygen. It's being used elsewhere in the body. So now that blood gets transported first to the right atria, and from there to the right ventricle, and from there to the lungs. And once it reaches the lungs, that's where the oxygen is picked up and carbon dioxide is let go. So we're exchanging the gases at the level of the lungs, and now the blood that returns from the lungs is rich in oxygen. So it's bright red. and you'll notice that it goes to the left side of the heart. So right side is all about dealing with blood that has very little oxygen in it. So now we get to the second circulatory system that I mentioned, that there's like almost 2 loops that we're dealing. We're looking at the left side of the heart. On the left side, we're receiving again blood to the atria. So you'll notice no matter on what side you are, it's always the atria that receives blood. Well, we're receiving the blood to the left atria. From there, it travels to the left ventricle and gets pumped out through aorta. Well, that blood goes to the rest of the body. So there is a systemic circulation or systemic circuit. So other than lungs, it covers all other parts of the body. And you'll notice that the loop that goes to the lungs, it's much smaller than this loop that goes to all other parts of the body. Because lungs are not really that far from the heart. There's not that much of a longer distance to go, but to go to everywhere else in the body, that is a long distance, and there's a lot of ground to cover. But that's what I want you to remember from this, that there is 2 halves. Right half deals with the deoxygenated blood. Left half deals with oxygenated blood, or reoxygenated blood, if you wish. And the right half was all about getting the blood that has little oxygen to the lungs and getting it oxygenated. And then it comes back to the left side. Left side deals with this oxygen-rich blood. So this is blood that we actually can use for something, and we pump it out from the left side. It goes to the body, does its business, and comes back to the heart as deoxygenated on the right side. So it really is like 2 hearts beating as one. And it really is like having 2 circulatory systems, or 2 loops, pulmonary loop and systemic loop. So that's the big things that I wanted to highlight on this diagram. Well, we're going to go one step further, unless someone has questions. I think that we're good. Yeah. So what we see here is that the strength, how strongly we're pumping the blood out, with how strong of a pressure out of the heart, that differs on 2 halves as well. So on the right side, which was all about pumping the blood to the lungs, we don't need that much pressure in there because lungs are not far away from the heart. So the distance is short, but also if there was too high pressure on this loop, the blood would actually end up leaking to your lungs. And that would not be good, having lungs full of blood. So there's a low pressure in the pulmonary loop. Well, this loop that goes to the rest of the body, because it's covering much greater area and to much greater distance, on this loop, we have a high pressure. So if you actually compare a heart physically and you look at the right side and left side, especially the ventricles, you'll notice that the left side has much thicker muscle because left side needs to squash that blood much more forcefully so it goes out of the heart and travels through entire systemic loop. Whereas right side, it doesn't have to squeeze that hard because it's easy to get the blood to the lungs. And actually, if it was to squeeze that blood really hard, we would end up breaking the small blood vessels in the lungs and we would end up drowning an individual in its own blood. That would be a sad way to go. So that's probably everything that I can think of in terms of adding to this picture. Does it make sense? Maybe yes. I see yes. That's good. Perfect. And again, you can review this and get all the full story with all the fine details on the lecture videos. But this is the big take-home message for this chapter. The other thing that I want to talk about, so that was like the first part. The second part that I want us to talk about is to actually look at the heart in detail, because that's the topic of this chapter. And you'll notice there's a really fancy drawing that we have here about the heart. We can see the right side. On the right side, at the superior part of the right side, so at the top part of the right side, we've got right atria. And at the inferior part, the bottom part of the right side, we have right ventricle. And same goes for the left side. We have left atria and left ventricle. And this is where you can see the muscle thickness difference between the right and left ventricle. So left ventricle is really much thicker in terms of the wall because it has to squeeze that blood stronger because we need the high blood pressure. Well, if you look at this diagram of the heart, I think it's pretty, but there's so much going on that if I were to ask someone to draw that in an exam, I think that would be a really mean question. So I'm never going to ask you to draw a heart. If you were asked to draw a heart, I'll show you what you can draw. Everyone can do this. You can draw a box that you divide in 4 different parts. That's a heart. That's as much artistic abilities as you need to have on this course. So you'll notice we have our right side here, we have our right atria and right ventricle. And then we have our left side, left atria and left ventricle. That is hard. So make your life easy when you're studying things. Simplify things. I use this same drawing in university classes for my students. And they're totally happy to draw that. And they score well because you can still explain an awful lot of facts, even with simplified detail or even with simplified drawing. You don't need to have that much detail. But if you really look at this and squeeze your eyes, you can kind of see those 4 boxes. So that's your heart. That's as much as I want you to know. And there are the labels, the very same labels that we could add to this drawing. And I will actually show this drawing with the same labels. But those labels can be associated with this simplified model of the heart that I provided here. So we see our right atria, right ventricle, left atria, and left ventricle. So all the things that we've been talking. Now, let's have a look of the flow of the blood through the heart, and we will have a look of it on this fancy drawing with these arrows, but let's keep it simple and start with a simple drawing on this simple diagram that we have. So we saw that the blood came to the heart on the right side. That's where the blood comes from the body, from the systemic circulation. And it comes from 2 different parts, but we're just going to focus just saying that blood comes to the right atria. And that's as much as we need to know. We don't need to know from how many places and in which way. But that blood is going to be deoxygenated, low in oxygen. So let's add that into this diagram. Blood comes from the body to right atria. Where does blood go from the right atria? Well, it of course goes to the right ventricle, so underneath it. And from the right ventricle, it gets pumped into the lungs. So that's the blood flow through the right-hand side of the heart. The very same thing that you see here with these fancy arrows. Blood coming to the right atria, from right atria to the right ventricle, and then to the lungs. So that's all that we have simplified here on this diagram of our heart. Well, let's have a look. Where does the blood come from the lungs then? Well, blood comes to the left side of the heart. This time it's rich in oxygen because it's been oxygenated now at the lungs, and it's bright red. So it comes to the left atria. And from the left atria, it travels to the left ventricle. And we'll notice that the left ventricular wall was thicker than on the right side. And from the left ventricle, it travels to aorta and rest of the body. So let's add that into this diagram. Blood comes from the lungs to the left atria. From the left atria, it travels to the left ventricle. And from the left ventricle, it travels to the rest of the body through aorta. So that's all there is to the blood flow. I could have probably made this in red color. I didn't think about that at the time when I prepared these slides because I was like trying to follow the college's color scheme. You can tell that I've tried to be really good with the branding. I keep changing the colors depending on which school I teach in. But really, that's all there is to the blood flow in the heart. It's really this simple. So that brings us to this diagram that we've seen before. Here we see the same blood flow. Blood coming to the right atria. And I can actually name these couple of vessels. And we'll talk about these vessels on the next chapter. So you don't need to worry about them now. But this would be inferior vena cava. This would be superior vena cava. They drain all the deoxygenated blood from your body. Then from the right atria, it goes to the right ventricle. And from right ventricle, it travels up the pulmonary trunk to the lungs. There, blood gets oxygenated and it comes back rich in oxygen to the left atria. And actually, there's 4 different openings. This just shows one. But left atria, from where it gets pumped to the left ventricle, you'll notice thick wall pumping really with high pressure to the aorta, and from there to all parts of the body within the systemic circulation. So we can label the very same parts that we saw in our simplified diagram. We see, I can just hear my cat jumping around where it shouldn't be jumping. That's when I was listening. I was like, is it ghosts? And then I remembered that I have. So we have our right atria and left atria. It looks a little bit harder on this fancy drawing, but it's all there. And then we have our right ventricle and left ventricle, just like we saw on that simplified diagram. So that's all I want to tell you, that it is really a good diagram for us to use. Well, one structure that I often ask from my students in an exam that totally throws them off. So I keep asking this question because it throws them off. No, I keep asking it because this is an important structure. Inside the heart, the 2 ventricles are separated by something that we call, let's see if I can do this with a highlighter. I'm having such a hard time using these tools. It's a structure called interventricular septum. And when you're trying to understand why structure has a name, break the name into different parts. It's going to be interesting. So it is 2 ventricles. So ventricular, between 2 ventricles, this wall, we have 1 ventricle here and another ventricle here. So it's in between those 2. The fact that it's inter tells us that it's between the 2 ventricles. And septum is the term we always use when we talk about some kind of a wall somewhere. So remember that this wall separating the 2 ventricles is called interventricular septum. It sounds like a mouthful, but when you break it into parts like that, it makes sense. Think of internet. Internet tells that we're connecting computers to each other. So interventricular connects the 2 ventricles to each other. And septum just tells us that it's a wall in anatomy. That's the fancy word we use for a wall. Now that we have covered the interventricular septum, what I'd like us to cover is going to be actually taking what we have learned one step further. What you'll notice that the flow of the blood is to one direction and one direction only. And that's the case because we have something known as valves here. So these little leaflets that prevent the blood from going back and only allow blood to go one way to the direction where we want it to go. So you'll notice that we've got 4 valves in the heart. And some of these we've shown like 2 flaps. Some of them we've shown more flaps there. But there's 4 valves that we need to know in the heart. Let's have a look through those. Well, the 2 first valves that are easy to name are our atrioventricular valves. So we abbreviate that as AV. It simply tells the name that it's in between atria and ventricle. And we have 1 on each side of the heart, 1 on right side and 1 on left side. So we have right AV valve and we have left AV valve. Well, because we're doing anatomy, and anatomists love to have multiple names for the same structure just to make students' life horrible. No, it's not for that reason, because one name tells one fact about something, but when we act more at a different name, it can tell another fact about that. So we don't always use the name right AV valve. Sometimes we might instead talk about, and I've added here a picture of the hard as we were looking it from upside down, and we have removed a lot of stuff. But you can see these valves that we've had. And if we're looking at the right AV valve, we'll notice that on this diagram, we see that there's actually 3 different leaflets. So 3 cusp-like, so kind of a 3 cup-like structures that form that valve. So that's why we call it tricuspid valve as well. So AV valve and tricuspid valve, it's the same thing. Which word we use depends. Do we want to highlight the fact that it's between atria and ventricle on the right side? Or do we want to highlight the fact that it has now 3 leaflets in that valve? So that's the reason why we have 2 names for the right AV. Remember, tri goes to the right side. Well, let's have a look what we can name the left side, left AV valve. Well, we've got 3 different names for it. We have the left AV valve. In addition, we can call it bicuspid valve because on the left AV valve, we only have 2 cusps, 2 leaflets there. So bi belongs to the left side. And one name that we often see being used, which is kind of a fancy name, I like the sound of that, it's the mitral valve. So the left AV valve can be called either left AV valve, bicuspid valve, or the mitral. All of those mean the same valve. But just so you're aware of that we have all these names. Do you need to know all these names? Unfortunately, yes. That would make a really good exam question to ask that, is the bicuspid valve same thing as mitral? Or is the tricuspid valve same as the left AV valve? And of course it wouldn't be. So it's just, again, remember your tests will be open book. So I would just make a really nice diagram of this for yourself. So you kind of have it all on your fingertips when the exam time comes. Did you have a question?
I do. I have a touch screen, and when I teach, I circle everything for my students. So I'm always like, here, right here. And that's what I just went to do. I went to go circle this, like I can do that with you. So the bicuspid and the tricuspid, the 2 at the very top. Mm-hmm. Yep, that, and then the one next to it. Yes. They're the only valves. Those are the valves, not the 2 below it.
These 2
with the red around and below.
These in a second.
Okay, but I just wanted to make sure that
you just need to know these 2.
That's the tricuspid and the bicuspid.
Really easy. The ones that we haven't covered yet. I always start with the hard and stuff.
I just didn't know if those were part of it, or if they were not part of it. But okay,
no, they are going to be. I love how you're thinking. You're already thinking ahead. So what I do again, these slides, I have very similar slides available to you as PDFs, and you can highlight things on those because that's how I learn. I learn with colors. I learn by doing that action of highlighting. So I'm loving the fact that that's the way you learn as well. And I think on an online setting, we're losing some of that doing stuff. So highlighting is a really good way of learning. So far, do we feel comfortable with the AV valves?
Yes, I do. I get them.
I know that it's a lot of names, but remember again, that's the beauty of this course, that you have all these available, these notes. So just make good notes for yourself. So let's have a look at these 2 valves that you were already having a think of about. And I love the fact that your mind was going there. You should be basically teaching this course. So let's have a look at what we've got for these 2. So we've got on the right side a valve that separates our right ventricle and our lungs. And the blood vessel that leads to the lungs is known as pulmonary trunk. So lungs, when we talk about lungs, we always talk about pulmonary something. So the name of this valve is really easy. It's just a pulmonary valve. It tells where the blood is going. So that's all there is to know about this valve. Well, on the left side then, we've got a little bit of a different thing. We've got our left ventricle and blood went to the rest of the body through an aorta. So why don't we call that then aortic valve? So really, these two valves are really easy to remember. You just name the place where the blood goes from there. It goes to the pulmonary trunk or it goes to the aorta. So if we add all of these different ways how we can call these, we can call pulmonary valve and aortic valve also both of those as semilunar valves. And that explains to what you were asking. If you look at this picture, they look exactly alike. So you can say that you have two semilunar valves. The name semilunar comes that the word luna refers to the moon and semi partial moon. Some say that these three leaflets here, they look like partial moons. I don't know. You need to have a little bit of imagination to see that. But instead of talking about a pulmonary valve and aortic valve, some people talk about the semilunar valves. So I would just focus on the pulmonary and aortic. So if you add all of these labels on this picture, this is the one that you want to be using when you're revising for the exam. So you want to know your right AV valve, which could be also called tricuspid valve, and your left AV valve, which could be also called bicuspid valve or mitral valve. And then you want to know your pulmonary valve and your aortic valve. And pulmonary valve and aortic valve, they could be called also semilunar valves. So that's all the names that I can ask, possibly summarized in one diagram. Does that kind of make sense? Maybe? I see nodding. That's
100%.
perfect.
No,
And if you were to want to use this diagram that you had before, you could add that here's our right AV valve, and here's then our, I don't know where you would add there, our pulmonary valve. Here's our left AV valve, and here's our aortic. So you can draw it in different ways, whatever works for you. So I'm just showing ways. Well, the reason why we talk about these heart valves so much is that sometimes they don't work well. Sometimes you might have valves that don't fully close, or that they don't work at all, and this would cause the blood now not to go only to one direction, but also flow back to the wrong direction within the heart. And if that were to happen, that would be dangerous. That would be problematic. So if that were to happen, we would actually hear that when we take a stethoscope and listen to the heart, that we hear a noise that we shouldn't hear, and that noise is that blood going backwards. Or we're not hearing the noise that the valves normally do. When they close, we'll hear slap. And when they open, we'll hear boom. And when they close, we'll hear again slap. So you wouldn't hear those sounds which you expect to hear. And that's why doctors, when you go to see a doctor, they always want to listen to your heart. So we always want to see that everything's working. And to me, it's amazing that a simple equipment as a stethoscope, you can already tell a lot about how heart works. So more simple the way to get information, better for us. So that's the clinical relevance of the valves. How do we feel? I think we've covered a lot. The next part that we're going to cover, that's for you if you're aiming for an A. If you're just aiming to get a pass, you can zone out for the next 5 minutes. So what we do next, we will talk actually about the surface of the heart, the surface anatomy of the heart. Because it's not just inside of the heart that we're interested. We're also interested, if we take the heart from the body, what sort of things do we see there? So that's where we're going to be focusing on. And I'm again trying to move these things so I can see all the same pictures that you're seeing. So I didn't mean to do that. So let's have a look what we've got here. The first groove, and all of these that I'm going to be talking about are various grooves that we end up seeing in the on the surface of the heart. The first that we're going to be talking about is our coronary sulcus. Coronary sulcus is also sometimes called as an atrioventricular groove. And I think that the word atrioventricular groove is better because it tells you where it's located. This groove separates atria and ventricle on both sides. So on this heart picture, you see here at the upper side, the atria, both on the right and left side. And there at the bottom, you see your ventricles. The ventricles, you can't quite tell where they are separated just yet. But you'll notice that the atrioventricular groove is this, my mouse keeps disappearing, is this groove that separates the atria from the ventricle. Well, the next one that we want to know and we want to talk about a little bit is our anterior interventricular sulcus. Sulcus is a fancy word for a groove. Well, if we see that the name is interventricular, it tells us that it's between the ventricles, right? So we go immediately to the area of ventricles, and we'll notice that the right and left side are separated by this groove that's located here. And it's on the front side of the heart, so it's anterior. This already gives us a clue that there's also going to be one similar one on the posterior side. So that's our anterior interventricular sulcus. And then we have our posterior, like I mentioned. I don't think that we see that on this diagram. I have plenty of diagrams on the actual lecture video, and on those slides, it would be here at the back. So we're not going to see it. I'm just trying to mark it as a dotted line. I don't know what happened there. But it would be behind the heart, separating again the two ventricles. So these grooves, you would be like, okay, why do I need to know this? Just because your instructor is mean. No, the reason why we study them is actually that we need these grooves when we are going to study the next topic of this chapter. And what we'll notice is that every living tissue in body requires blood. All tissues require blood because blood brought to the tissues oxygen and nutrients. And blood also took away the carbon dioxide and waste products. Well, what would be the most active organ in the body? Well, that's heart. So heart must pump blood to itself. Because heart works so hard, we need to make sure that it also receives a sufficient amount of blood supply. And this picture that you see here is actually one of my favorites. What we've done there, we've filled the blood vessels that supply the heart with a plastic, and then we've dissolved everything else away, all of the heart muscle. And you'll see how much blood vessels there really are around the heart, because heart needs so much blood because it's such an active organ. So that's the big message here, that we take care of the number one, and heart thinks that the number one is myself. So we have a special circulation that supplies the heart itself. And if you are chasing for that an A that I mentioned, one of my favorite questions to trick students, not to trick students, but to test who's aiming for an A and who's aiming for a D, is to ask that, okay, we now have the heart here, and this is the aorta. Blood comes out of the heart and travels to the aorta. And I ask often students that what is the first artery that comes in aorta after the aortic valve? And a lot of the time students are really proud because they have studied these blood vessels, and we'll talk about this on the next chapter. But these students are so proud that they forget that we've actually got two little blood vessels here right after the valve. And these are known as our coronary arteries. So these are the blood vessels that supply the heart itself. And these are the blood vessels that we always want to make sure that are always receiving blood. So even if we would have issues somewhere else along the aorta, the very first two blood vessels are the ones that supply the heart itself. So they're very, very important. And this is why we studied all these grooves earlier on, because these grooves are where these blood vessels that we'll see are located. So let's have a look. Like I said, I made a career out of studying 3 blood vessels. There's only 3 coronary arteries you need to know. Let's have a look of those. So we saw that we had 2 coronary arteries that came out of right underneath or right after that aortic valve. Well, one of them is left and the other one of them is right. So we've got our left coronary artery and then we've got our right coronary. Well, the left coronary artery very soon, just after a little distance, divides into 2. First part of it is known as left anterior descending artery, or some call it anterior interventricular artery. Doesn't that name tell us where it's located? Again, that interventricular space. We saw that groove, anterior interventricular space. So that's the first blood vessel that we need to know. The other branch of the left coronary artery that we end up seeing is our circumflex artery, often abbreviated as LCX. In medicine, we like to use abbreviations. So circumflex artery does what the name suggests. It goes around the heart. It circles the heart. So it goes to the behind and runs there all the way to the back of the heart. You have to go? I can't hear you, but if you have to...
I have to teach a class. I'm going to be late. I forgot. I thought I had to teach at 10. I have to teach at 9:30 and I'm going to be late.
Go for it. There will be a recording.
I'm so sorry. I'm so sorry.
No. There will be a recording. Go to your class.
Okay. I'm so sorry. Goodbye.
No, goodbye, bye.
Bye. Oh, I'm so sorry.
No, don't be sorry. Go for it. So I'm going to finish off this recording so that the rest of the students who come back to look at that can find it. So we have covered the left coronary artery now. Left coronary artery divided into anterior interventricular artery and into circumflex artery. Well, we also had our right coronary artery. And let's have a look of the right coronary artery a little bit. Right coronary artery comes out on the right side of the heart and it runs in this groove between atria and ventricle on the right side. And it actually runs all the way to the back of the heart here. So we notice that the blood supply to the back of the heart comes both from the right side and from the left side as the left circumflex. So we've got 3 blood vessels, we've covered those, and those would be the important ones to know for the heart and as the coronary arteries. There are also veins that collect the blood from the cardiac muscle. However, veins in general in the human body are much less regular. They're a little bit more unpredictable. In terms of the coronary veins, there are some that are fairly obvious and that are fairly clear ones, but we won't spend any time studying them. So I'll just mention that there are veins also at the heart. Now the next topic, we're moving a little bit away from our anatomy and we're going to look rest of the chapter, physiology of the heart. Well, let's go through the physiology. So what I want to show you that the heart has a basic rhythm and we're going to be talking about that. And that rhythm is maintained by electrical impulses, just like we saw the action potentials in nervous system. However, these impulses differ a little bit. And the biggest difference between these is the fact that, I need to move a box to be able to show, the fact that the heart action potentials, cardiac action potentials, actually are much slower than the nervous system action potentials. And there's a very good reason for why they are much slower. They're much slower so that the blood has time to flow from where it's flowing to where it's meant to flow. So there's a delay on purpose for the speed at which speed the blood, in which speed the action potential passes within the heart. So much slower than the nervous system action potential. And let's follow through the action potential within the heart tissue. And we'll be focusing on this diagram on the right side of the screen. So let's go through how the action potential spreads throughout the heart. Well, heart's action potential starts from a group of cells that are shown here with the orange dots. And this group of cells are known as our pacemaker cells. Remember, the individuals who have problems with the electrical conductance of their heart, they might have installed a pacemaker. That's doing this job that we're going to be looking at now in an artificial way. But in a normal, healthy person, in your heart, you've got located here on the right atria, superior part of the right atria, this group of cells known as the pacemaker cells. When these pacemaker cells send an action potential, that action potential spreads throughout all of the atria, both on the right side and on the left side of the heart. Once the electrical signal has spread from the pacemaker throughout the atria, it reaches a point known as AV node. AV node is located between the atria and ventricle on the right-hand side. AV node plays an important role in the function of the heart by acting as a relay station for this electrical signal. So the electrical signal pauses for a moment, and only after it has paused for a moment, we let this electrical signal travel down. We are traveling down this interventricular septum, which I mentioned before. So it travels on this wall between the two ventricles. Some of these fibers there that carry the action potential of the heart are known as Purkinje fibers as well. And after that, once the action potential has reached the tip of the heart, the apex of the heart, it starts climbing up to the walls of the ventricle. So you'll notice that this action potential spreads through the heart, covering first atria, then taking a short break, and then covering ventricle. And this break is important because we want the atria to contract first, and once they have contracted, they start relaxing, and at that same time, ventricles are contracting. So you never have both contracted at the same time. And by having this rhythmical pattern, we're ensuring that this pump works correctly and we're constantly moving blood ahead. And this was all to do what we discussed about the special characteristics of the cardiac muscle cells. The idea behind that is that we let the muscles contract in a synchronized manner, but we make a little break. We take a little bit of a time off between atria and ventricle so that the signal doesn't spread immediately at the same time to the two places. So that's what I've got to say about the about our electrical propagation of electrical action potential within the heart tissue. I hope that makes sense. That's an important concept. And here I'm just showing some relevance why we need to know about this. We might have an individual whose cardiac rhythm is not following the pattern that we're expecting. It's irregular, or it might be completely out of sync, and it might be just that everything is contracting all the time. Heart goes into something that we call fibrillation. Well, really, one of the tools and one time that you can actually save someone's life in first aid is by using AED, automated external defibrillator. That's the machine that you see on that picture. That's the machine that you can find in many shopping centers, schools, public places, inside this little box that you can break or you can open. And what you do with that, you put those pads on an individual and it delivers an electrical shock to that individual. And we try to make sure that that electrical shock travels through the heart. The purpose of doing this is that we hope that by giving this electrical shock, we're able to shock the heart back to a normal rhythm. So that's the clinical relevance of what we've just discussed. Let's have a look what else we can find here. You can also have an individual who needs a pacemaker implanted into their body. I think I mentioned that. I don't really expect you to go into great details of knowing that. I'll just tell you, because I've done so many postmortems, the individuals who have this pacemaker, it's not just a pacemaker. From the pacemaker, there's a metal wire or a bunch of wires that then go around the heart that delivers the actual electrical impulse. And quite an interesting branch or interesting fact that relates to that, and again, not in your exam, is that actually we reuse these pacemakers. Not within here, Western world, but a lot of the time when we have an individual who has died and they have perfectly good pacemaker inside them, and if we are doing post-mortem to them, we might remove that pacemaker. It gets sent to a company where they refurbish that, fix it so that it can be used again, and then it gets shipped to the third world countries where they get reused a lot of. Just a funny story about pacemakers. So let's continue our chapter material. The next point that I want to discuss about with you, and this is one of the labs that you'll be doing today, doing on this module. We'll be talking about electrocardiograms, ECGs. ECGs are simply a recording of those electrical currents within your heart, recording of those action potentials as they travel through your heart. And you might have seen that to record an ECG, we put a number of LEDs across your chest so that we cover different parts of the heart. We might put also a control LED to your wrist or to your ankle or wherever. The point is that what you see are these multiple different graphs or multiple different lines that are being drawn, one from each LED. But then we sum all of these lines together to produce one basic line, or we pick one of those lines that we were looking. And that's this wiggly line that you see here on the right side of the screen. And what we'll notice, this wiggly line in a healthy individual has always certain elements that we can spot from. Let's go through those elements that you should be able to spot from an ECG, because I want you to be able to name these. And while we're covering this, you'll see what a normal ECG trace looks for one single heartbeat. So the first bump or elevation on this line that we see is our P wave that we see here. After P wave, we'll notice that there's a group of movements. First, the electrical activity, or the graph showing that, goes down a little bit, then shoots up significantly, and then shoots down significantly again. This bunch of 3 different points has been named with 3 different letters. This section is known as our QRS complex. So complex because they're all packed closely together. So our QRS complex. After QRS complex, in a bit, we'll also see our T wave. So those are the parts of an typical ECG that I want you to be able to name. Our P wave, our QRS complex, and our T wave. And when you are analyzing an ECG graph, you might notice that one of these is missing, or there's an unusually long gap between those, or one of these might be skipped every now and then. So we are always analyzing these characteristics as vital parts that we want to note from the ECG trace. And as you can see, we can calculate various distances between these bumps. They work as a very good way of quantifying that are we seeing that something's taking longer or shorter from what we normally expect to see. So as I said, this shows one single heartbeat. And these are the elements that I want you to know from the ECG. The next thing that I have about the heart physiology, I've got two terms that I want you to know. And the two terms that I want to discuss with you are really quite basic, but quite useful for us to know. So when the heart is contracted, we talk about the heart being in systole. Or we can talk about atrial contraction. So we talk about atrial systole. So we use the term systole to describe the time period during which some structure is contracted to very small. And the word diastole refers to the time period when this structure is relaxed. So we can have ventricles, for example, in a diastole. That means that these ventricles are relaxed and grow to be big as they are getting filled with blood. How do you remember these? Well, I remember that there's a pair of systole and diastole, and then I think of what happens when you relax. Well, when you're very relaxed, for example, a heart chamber, it dilates. So that's my mnemonic for remembering the diastole. And systole is an opposite of that, the contraction of a ventricle. What else can we talk about? Let's talk about the sounds of the heart that we can hear. There's two sounds that we typically hear when we listen hard with a stethoscope. It's often described as kind of a lup-up, lup-up, lup-up. And those sounds are sounds that result from closing of different valves. So the first sound is when the AV valves close, both at the right and left side. And the second sound is when the semilunar valves close, both on the right and the left side. So you remember the semilunar valves referred to our pulmonary valve and our aortic. So we will listen that does it sound normal? Does it sound like they don't close properly? Can we hear blood flowing to a wrong direction? And all that. And when we don't hear anything, we know that the heart is at that part relaxed. And when you go to a doctor and doctor listens to your heart, doctor will typically listen to your heart from 4 different spots. And this is because these 4 different spots are used to listen mainly one of the each valves. So that allows us to focus on separate valves as we're listening. So that's the relevance, clinical relevance. And the clinical relevance relating to using the stethoscope is that if we have issues with the valves, we might hear something known as heart murmurs. So abnormal heart sounds that we hear when the valve has failed and blood is flowing where it shouldn't be flowing, or the heart valve is not closing completely, or it might not be working. So many different things. And we can fix a lot of issues these days. There's artificial heart valves. We can actually even have heart valves move from pigs to humans, and so on and so on. But this is a very simple, again, very basic test. Let's listen to the heart. And from those sounds, we can tell a lot about the health of an individual. And the very last concept that I want to highlight on this chapter is concept of cardiac output. Cardiac output is often abbreviated as CO. So we're talking about how much blood is pumped out within 1 minute. Well, if you try to quantify the amount of how much blood is pumped out of the heart within 1 minute, you will need to look at two different factors. You need to look at your heart rate, so how fast your heart beats, and you need to also look at how much blood leaves the heart with each beat. If you multiply the amount of blood that leaves the heart with each beat, one single beat, by the heart rate, you get our cardiac output for the entire heart within 1 minute. So that's the final concept that I wanted to discuss regarding this chapter. So we have really covered quite a bit here. We have covered all of the key points of this chapter. And I know that this was a little bit longer of a review video than normal. But that's because heart is really fascinating organ and I love it. And I think that there's so much to discuss. Well, let's go back here. I just have included this slide to remind you that first of all, I'm so happy to organize one-on-one sessions with you, small study group sessions with you, or even these sessions that are open to an entire class. So feel free to let me know if you would like to have one of those sessions and we can organize one, or you can join me on Wednesdays, either in the morning at 10 o'clock in the morning or in the evening at 8 o'clock. And I promise that I'll try to make these a little shorter so we don't overrun as much, so you can plan your day accordingly. If you also I wanted to include this slide to show you that we have great tutoring services available for you. And now during remote working, we're offering this tutoring through this Cranium Cafe platform. That's the one that I discussed to you at the beginning of the course. So our tutors are available for you from there as well. But like I said, I am here to help you as well. So please don't hesitate to let me know how I can help you to be successful. Well, at this point, I would ask questions or open the floor for questions, but I think that we don't have any on this small group that we're looking at. So I'm just going to jump to the next slide and come back to the questions if there's some of the recording. But we'll see that we have covered quite a bit. I really want to remind you about the PHILS labs, that it might take a little while to figure out how those work, so don't leave your labs this week at the very last moment. And if you run into the issues, remember that that's probably because of the PHILS labs using the Flash player, and because Flash player is a little bit temperamental, please follow those extra videos that we have included in the Canvas in this learning module for you, what to do, how to make sure that your Flash works. And if you get stuck, don't remain stuck. Reach out to me or reach out to the McGraw-Hill's tech line. They know to expect phone calls. They know that it's a little bit clunky, and they're more than happy to help you. So I think that completes everything that I had for this review session or this weekly live online session. And I'm going to stop recording now just in case there's anything that we want to discuss off recording. But I hope it's been helpful for you. And like I said, I'm happy to do these at any time, any day. Just let me know if one time works better for you than another. Thank you again.